Hi friends, this is Dan coming at you from the Not So Secret Laboratory. Hope you got your plushy squeeze ball or other stress relieving device ready for you because we're going to try learning a new IDE, which is always super stressful. I'm going to hopefully help you take some of the stress out of that by showing you the things that I struggled with the first time I started using the Renesas E2 Studio IDE. I'm actually an employee of Renesas, but I wasn't a few years ago. I was a part of a company they acquired, so I'm like the total noob, and I don't know how to do anything. And then COVID hits, and I have nobody in my cubicle to explain everything to me. So I kind of struggled through this, and I'm going to coach you guys through as well. So first question is, why should I be using Renesas parts? Well, Renesas has 1 billion microcontrollers. They're one of the largest microcontroller companies on the planet, which I found out. I had no idea who's Renesas, right? But they've got a bunch of really cool stuff coming down the pipeline. And if you want to be part of that action, you got to check out their tools. So what we're going to do is jump onto a screen share here, and I'm going to show you how to find E2 Studio, which is their IDE. It's like Tile or IAR. So the first thing you want to decide is, well, if I'm going to develop with Renesas tools, what should I use? Well, if you've got IAR, you can just use IAR. If not, you probably want to use E2 Studio. It's a derivative of Eclipse, very familiar to a lot of programmers. I'm not a good programmer, so it wasn't very familiar to me. I mean, I had used Eclipse before, but still it was tricky. So what we're going to do is we're going to go to renesas.com. We're going to try and find E2 Studio. So here we go, design and support. And then is it software and drivers or development tools? Turns out it's development tools. And you get in here and there's like 150,000 of them. So you're like, okay, what do I do? What do I do? Type in E2 Studio and you get nothing because it wants that little squared button there. So the best thing to do is just type studio like that. And there it is, E2 Studio. We can download that, or just like Google did it for you, download E2 Studio. And it takes you to the same website. So there we go, download E2 Studio. And so what we're going to do is, take a break. It's going to take, several hours to install typically, depending on how fast your computer is. But the downloads here is you want the E2 Studio installer for Windows typically. So we would click this, and I don't necessarily want the update for the documents. And then you're going to create a Renesas login to do that. And then you can download the IDE. I'm not going to coach you through that process. My advice is to select every possible option for tool to install. That way you don't have to install it later. It adds a little bit to the install time, but it's not so easy to add tools after the fact. You think it would be using Eclipse, but they're going to fix that in the future, I know. But for now, just install everything. On the other hand, if you're using RA, which is their new ARM-based microcontroller line, you want to be downloading FSP, which is a flexible software platform. What is that? It's like a HAL, but it does its own installation of E2 Studio. So you got to do that. So you just download FSP, right? And it'll take you to a different place. If you've got the current version of E2 Studio, it'll install FSP over the top of that version. If not, it'll install a new version of Renesas. So once you've decided if you're using IAR or E2 Studio, you run into this problem of which version of E2 Studio to use. And in our case here, unlabeled, we've got 3 different versions, and we have no idea what they are. I just have to remember, use this one, it's the latest. So just remember that when you install a new one, check it out and just memorize where it is. You have to remember where it is. So you open up E2 Studio. It's going to give you a welcome screen. You close it, and then you can do all the normal things you can do with Eclipse. You can, for instance, just do File New, and then you can do a new project and click here in General. We're going to select a project, C++, a project like this. And then now it gives us all these. Now we're starting to see the power of this integrated environment. Now we can choose whatever we want. So there's 2 different compilers they have listed here. I know they're adding more in the future. So if you're hoping for a specific compiler, you'll probably get your wish granted very soon. Renesas is adding features really fast, and their UX is just improving like by the day. So if there's anything, oh yeah, and if you're not familiar with working with Renesas, the thing you like is like their customer support is like phenomenal. So if you actually ask a question or go to their website and someone will like call you, it's amazing. Yeah, they're incredible with customer support. So hooray! If you're used to just never getting a person, then you will love working with Renesas. That's really cool. They even called me. I'm like an employee. They're like, hey, did you get everything you needed? I'm like, wow. So there's GCC, which is an open source compiler. I found it sometimes to be a little less reliable. There's also this CCRL for their low end. L stands for low end. Actually, it stands for it's their 16-bit line. Or CCRX, which is a sort of like super. That's like a performance engine. You know, it's designed to be just like it's just that much better than other 32-bit platforms. But you know, it's not necessarily ARM, so not all your code's going to port over. So you have to learn some new things. But they do have a really nice HAL for it. And lots of features you can get there. So decide if you want to use their proprietary compiler. You have to buy a license to it, I think. So that's one reason to use GCC. If it's a simple project, if you can't do it with GCC, you can always jump over and try CCRL. So you define your project you want to use, and then you hit next, and then you give it a project name. You practice, right? It's going to send it to a default location. One thing that I wanted to mention here is you can actually import Git from Git directly into E2 Studio, and I use that a lot. So I use this users/my name/git, and then I just put my projects in there, and they'll automatically update. It's super nice. And so then I'm going to choose a C project. I got my tool chain versions, everything, and I'm going to tell it the target device. So here you got to tell it a device. E2 Studio is kind of good at switching devices, but not totally good. There's a few little things there. Hopefully I'll do a video in the future on what the gotchas are in switching devices. So try as best as you can to choose the device you want before you start. So I'll say, oh, I want G14 is a sort of general processor, and they have different, you know, package versions with pinouts and different memory versions, but I could just pick a random one here. And then this will then start us into the project, and it'll open up something completely empty and blank with nothing very interesting. And that is, it's like, what am I supposed to do now? Well, the good thing is that Renesas has these things called code generators or configurators, where you can just go through and click options you want. I want to use this speed of clock, and I want to include this peripheral and that. It'll just generate a whole bunch of example code for you. So you're going to love that. So that's this code generator feature down here. And if it doesn't show up, I think there's a button you can click somewhere that like gives you a code generator. I heard someone found it once. There it is, new code generator. That's the button that will generate a new code generator. I didn't find out where that project that I tried to open up went. Anyway, oh, there it is. It just opened up there. So here in the Project Explorer, you can see I've got two projects open. You never want to have a project open. We'll close this one. Close that project. Okay. And now this project is already open here. So here in this practice project, we've got some source code, and basically we double click on this and it opens up and we basically have nothing, right? So it's like, oh no, where do I start? So yeah, we're gonna come up here and we're gonna try to find that new code generator button. Where was it? It was up here somewhere. Oh, there it is, new code generator. This is the first time I've ever done that. Please select a project. I want this one. Try this. There we go. It's going to generate a new code generator, and this you're going to love. You can open these things up. You can be like, okay, I want to get a port. So it's going to open up this nice window for you. And no, I don't need the code preview. Sorry. Yes, this thing up here, this whole window right here. There's different bits you can set that will switch the pinouts, which is kind of unique. I typically don't click any of these, just use the default pinout because that's the one it shows in the datasheet. If I need other pins, just get the package with more pins. Renesas has like an infinite number of packages. So you can see the clock setting. You want to choose, you know, different voltage levels can have different clock settings. You can run faster the higher the voltage you're supplying. So that's a good thing to know. You can turn on the real-time clock here. You can turn on the you know, the watchdog timer. You can just turn on anything, right? So I'm going to go into serial here, and you can choose once you've selected these things, and you can select all your SPI or I2C or however you want to configure all your peripherals. Then you just click generate code over here, and it's going to give you some simple code to work from. And unfortunately, it's not super well documented. There's usually a bunch of functions with some callbacks, and it doesn't tell you which function calls which callbacks. You have to just be smart and guess which one's which, or put breakpoints in. And that's the other way to do it. A little bit more challenging from that perspective. Okay, so now we're going to open this project. This is an existing project that I was working on. We're going to close this one because it gets super confused. if you have two of them open, you can't you try to compile it, it'll compile the wrong one, and you're like, what the heck? Okay, so one of the things that just drove me nuts when I first was using E2 Studio is I would have some like file open, right? I'd have some file open and I would click on it, but then I would accidentally double click and everything would go and be like, oh crap, what have I done? Everything's gone. I'd be like, oh, up here, like a window, appearance, and nothing fixes it. Turns out you just double click back on it and it returns. So anyway, that's the double click feature. It's great for when you really want to see your code and just can't be bothered with anything else. And then when you want to go back and see all your menus and stuff, you're there. Okay, so there's a whole bunch of other buttons up here, all of which do things that I don't know what they are. But the debug menu actually gives this ability to step through your code. So if I hit this, I have to start debugging first. You have to teach it how to debug, and we're going to get there. But I just wanted to talk about these views here. So this is the main C++ view, shows you all this good stuff. This is the debug view, and the debug view has a bunch of other nice windows. The variables window, this will show the local variables in a function. And until you turn on optimization, you can see pretty much everything. And then once you turn on optimization, some of those things will just stop showing up. They'll be optimized out. So there's an option called like debug optimizer. It'll just optimize it so that nothing gets optimized out. That's the default. And then you can do like speed or code size. And there's some pitfalls with speed. You have to sometimes if you have a loop or something, an if statement that's really short, you have to put a no op in there, make sure it doesn't get optimized out. Sometimes it's just reality. Okay, so you got your breakpoints here. You can turn breakpoints on and off if you have lots of breakpoints in your code. Here, the first time in E2 Studio, when you double click on something to set a breakpoint, let's just maybe go back to the C++ window here. Let's just go down to a section of code that actually runs. So here's this oximeter.c. Okay, here's the C. So I can actually try to install down here in some function. Okay, I want to put okay, it's going to place a breakpoint, the next available operation. Well, it'll have like a square one here, which is the hardware breakpoint. But there's only one hardware breakpoint, which is like completely useless. So you basically have to right click and you have to basically switch default E2 Studio breakpoint to software. And you click that one, and then ever after I give you these nice round ones. You can put as many as you want. You can put them wherever the heck you want. Nobody cares. And then when you switch to your debug view, now you can see all these breakpoints. Be like, I don't want any of them, and now they're not going to run. Or you can just delete them from here. Like remove all. Okay, all my breakpoints are gone. See, there you go. That would have taken you a while to figure out, right? I can only put one breakpoint in. Expressions. This is super useful window. So if you just want to see a variable as it's being run during the program, you can just put any variable with global scope here, like my favorite variable, right? And it'll just show the value here. It's great. And you can actually even turn it on what's called like watch. You can turn it on like real time, and you can even add a chart and it'll like make a graph and plot it for you. So that's pretty nice. You can do that, and I can just be like, oh, I don't want this anymore, and just like remove. So any variable with global scope will show up here. If it's got local scope, you got to watch it here. And these things, unless they're on the live update, then you won't see them unless you click pause here, this pause button when you're in debug mode. But the other cool thing you can do is there's some other windows here I don't know what they are, like event points, and oh, this is useful. Rather than having to switch, if you want to open up another file and look at something while you're debugging, you don't have to switch back to this view to find the file. You can actually stay in debug mode, and here's your file menu here, and you can just open that up and it'll show it right here. You want to put like a breakpoint there or something like that. So that's kind of useful. I don't know what the peripherals and the event points and the modules are. I think the modules, this comes in for like RX or other things with like more advanced modules, but this is the most useful. This is where the IO registers show up. So this is like all the on-chip registers. You can just see them all. And there's a really useful feature where you can right click and just like export all. It'll save all the registers, and you'll change something in your code, run it again, and then stop it and export all those and use a tool like Meld or like Notepad++. You just line compare them. You can find exactly which register is different and be like, I know what's wrong, why it's working or why it's not working. So that's really useful. And I found it's almost always easier to export all of them and just navigate through them in the XML file that it exports, which is just a text file. So that's really useful. So there's this like button here you'd never notice. This is open perspective. And this allows you to open up whatever perspectives you want, like FSP configuration, debug, code generator, C++. This is basically all you really. So anyway, now we're getting the hang of it. So now we maybe just want to actually try debugging. So we'd normally be writing code, we'd be in the C++ dialog here. Before we want to actually go debugging, we have to compile the code. So you normally click this hammer button to compile, but you don't really know what you're compiling once you tell it. So let's right click on here, and this is going to take us to properties. We want to go to properties, and all the good stuff is hidden down here in C++ build settings. This is where all the good stuff is hidden. Like it's this one tiny little menu, but actually this is the menu that's like life, the universe, and everything. So you've got all these tabs, and under the first tab, you've got these millions of options, and every single option has like menus that you can click. So one of the things you might want to do is export a binary file that you can just use the Renesas programming tool. What's it called? Scroll down. It installs with E2 Studio, but it's called Renesas Electronics Utilities. This one, Renesas Flash Programmer. So that one you can just use to flash microcontroller you have on your desk or whatever. So if you want to use the Renesas Flash Programmer, you actually have to have a hex file or binary file. So you have to come in here and click this button. It's not clicked by default. What? It'll export like a debug file, but it won't actually export the hex. So you have to tell it. And that's down here in converter output. So you click converter, output, click the hex file. And there's two different options, right? So the .mot is like a .x. Anyway, that's one of the files you can get. Some other good options here. Here's optimization down here. So you can click it. You can do speed, safe, custom, whatever. I've got it on no optimization, so it's easy to step through and debug. And then you can also create different configurations where these settings are different. And that's done by right-clicking in this menu over here and doing. We'll just show you that real quick. So if you're anywhere in your project and you right-click and go to property, oh yeah, you can do build configurations. You just do manage, and you can add a new configuration, and it'll just take whatever your current configuration is, give it a name or description, and save it. And then up here you'll have different options. Up here you'll have different options for which configuration you want to build or debug. And you can also build, if you have multiple configurations, like one with optimization, one without, or something like that, you can just build them all if you want. A lot of times it'll clean it and build them all. So that's really good. Basically we're getting closer now. So now we're going to go here, we're going to tell it to just clean the project, which just erases all the files. And if something doesn't work, you can always just delete the folder, delete the like hardware debug or release folder where it's saving all these files, and then it'll regenerate everything in there. So it's going through and it's taking all my fancy pants code and deleting it all. And now I can just click build all. And one of the cool things you'll like about this, especially if you use something like Arduino or embed even, watch how fast this compiles. It's so fast. These smaller projects they just compile like at the speed of light, you know. So and they flash really fast too. So that's really nice. So this is a full clean, right? This is like everything. If I just did an incremental change, like I just changed one file, it would compile in like 10 seconds. I'll show you that, watch. So I'll take this file, I'll put an enter there, I'll save it, and I'll just hit build. And that's basically done right there. So that's how fast it compiles. It's like 3 seconds. So you'll love that if you're used to using something where it recompiles the whole thing every time, like Arduino. That'll just save you infinity time. So now we're going to debug here, and so there's these. You can click this debug thing, but you never know which version it's going to debug or whatever. So you kind of got to tell it. So the first thing you're going to do is go down here to debug as, and open up debug configurations. There's all this stuff you don't really care about. All you care about is Renesas GDB hardware debugging. That's this thing right here. And see, I've got a little one set up here. If you don't, you can just create one by right-clicking there. So press the new configuration button to generate a new one. That would probably be here, right? Yeah. Click this new one, it'll generate a new configuration. So I'm going to go to this. So this is an existing configuration. There's not that much important here. This tells it what file to use. So if you create a new configuration, you just browse to the .x file that you want to debug with, and it'll and just select it there. And you can name this something other than the project, which I wouldn't understand why you want to do that. But coming over to debugger, the secret sauce right here is, here's your target device. And this probably should match the target device that you defined in your project. If it doesn't, then it's going to give you a warning, but usually it works. These guys are pretty flexible. The other thing you really want to check here is on your connection settings, basically whether you want to supply the voltage from the emulator. So if you're actually using the programmer to power your microcontroller, you want to click yes. But if you're like powering it from USB or from a battery or something else, you want to click no. That's super important. And then there's like a couple other debug tool settings that you might care about. But anyway, it's this second window, that one there. That's important. Don't forget that guy. Oh yeah, and this is where you can set up, what clocks it's using and stuff like that. But I would just let those leave them, as is. And then you click debug. Okay. So then what it's going to do is it's going to throw an error because you forgot to plug your programmer in, and that's like, they call that the target. So the target is the programmer. They're going to update the error code, error codes on this, so that'll be good. So the bigger the numbers you see coming down here in this window down here, the farther along it's getting. And then the next thing it's going to show you is the next thing that it's going to show you is it's going to complain that you forgot that your device isn't powered. It's like, oh yeah. So you can't just power your microcontroller. You also have to power the power. That power has to route to the programmer pin. So you have to make sure those two powers are both connected and high. Because if the power line from the programmer is not being pulled high by the device, then it's like, oh, your device isn't powered. Even if it is powered, it says I'm not powered, so I assume your device isn't powered, so I'm not talking to it. But this is my E1 programmer. It's the old school version. Has all these like tons and tons of pins coming out, but it turns out all you need is 4: power, ground, tool 0, reset. So it's like 4 pins. So I've got a little breakout board that I built for this to do this. Otherwise, you have to do a bunch of soldering and like read some app notes and stuff. It's like secret knowledge how to do that. But somehow you can get it down to just 4 pins, and then it works. And this is the new E2 Lite programmer, which is great and cheaper. It's like $60 or something. Just use that one. So anyway, when it starts, when you debug, it's going to stop here in this cstart.asm. Apparently that means assembly. I don't know anything about assembly code, but it stops it right here. So you have to click play. And then there's an option in the debugger where you can turn it on and off, but it'll also stop at like the first line in main. And apparently I have that turned off because the code is already running. And you can see my device here with my device here with my little LCD display is on. Okay, so, and then if I want to stop it, I hit pause. And now it's just stuck in some loop. It's reading some time or whatever, and it's just frozen in time. And I can come over here, and now all these IO registers are populated. I can be like, oh, look, on port 1, pin number 4 is high. Cool, huh? You can just read the registers off right here. You can see everything. And then you've got all your, these, I think, different special functions registers and stuff. So anyway, in the data sheet, these all have like an extra letter on them. But in the code, you only refer to them by their last 16 digits as the address. So that's confusing. You have to know that. That's secret knowledge. And then somewhere in your code, actually, I can find it here. Somewhere in your code, there's like a file that actually tells what all the register names are. It's hidden in here somewhere. But if you see one registered, if you see a like this right here, like this, I just click on this. I control click on this, and it takes me to this file, which is io-define.h. Oh, great, io-define.h. We just found it. That's the file where you can find all of the registers defined. Isn't that nice? All of them defined nicely here, and you can just take this register name, and you can just write like RMC equals 1, and it'll just set that first bit in that register. So it's really easy to write code that way. And yeah, I can close these files later. And now that I'm closed, I can just be like, I can step over the next line, right? And I can just step over. But if I get to a function and I want to get into it, then I'll use this button to step into that function, and this one will step me out of that function. So you can just navigate up and through your code that way. Let me check my list of things I was going to talk about. Figured out how to get a binary, figured out how to turn the voltage on and off, configurations, optimizer, debug menu registers. Yeah, we pretty much got everything. Yeah, we talked about the dreaded double click, opening the right version, you just got to remember. How to get a new code configurator. That's great. So yeah, hopefully when I learn more, I'll do one of these on RX or RZ. But that's basically what we've got now. So I hope you guys enjoyed that little short introduction to E2 Studio, all the little awkward pitfalls that I didn't get, not being a super software expert. You know, when you're done here, you can click stop. And in this case, actually, this actually holds now. Sometimes you have to disconnect your programmer if you do that, or reset your device. But once you start running again, you can click this either restart or reset button. Don't ask me which one's which. But they'll restart your device, and you can just you don't even have to click the button on your board. You can just reset from here, and that's nice. Especially if you're changing like data flash or something like that, you can restart here, and that takes you back to the beginning of the program, but it doesn't change the flash. That's all really useful. And like I said, once you've got a binary and you just want to flash it to a board and you don't want to be bothered with opening E2 Studio, which takes 5 minutes, then you just come down here to Renesas Utilities. You grab the Flash Programmer tool, which is really simple, easy. File new project. We've got our new project here. We're going to pick this microcontroller RL78. Past, right? We're going to go browsing through somewhere, and we're going to find some binary files somewhere. Oh yeah, in Git. This is where I love the way it syncs with Git. It's awesome. It just updates everything on the fly. So then here, I can just get, this is the same program I was working on. I can go in here and I can find, you know, like a generated file. But that's actually where I saved the file. The program file is the one I want. And then you come in here for the program file, and it's glad to give me a oh, there was the .mot file. There it is, that right there. It'll take that one, and we just click start, and it connects to the tool, and it flashes it in like really fast. It's done. Like compared to the 45 seconds or a minute you're waiting for Arduino or Embed to like flash your device, it's like seconds. Done. Okay, and I can just start. And then now it's programmed. I can disconnect the programmer, program and export. So yeah, if you guys are interested in like more information, the Renesas Rules RULZ forum has a lot of information there. But man, if you can get in contact with one of the sales reps, these guys, or the applications engineers, these guys are like amazing on tech support. They will walk you through everything. You will never get better customer support. If you're not used to that, if you're just used to being American enough to solve problems on your own, you'll love working with a company like Renesas. Has its roots based in Japan. The customer is the boss, right? So you'll love that experience. And if you have any other questions, just put them in the comments. I'll try and hook you up with some engineers who actually know what they're doing. So enjoy. Thanks.